Hello everyone. Today I want to explain about the one of the very important NEMO reaction that is called Williamson synthesis reaction. Sodium alkoxide plus alkyl halide. These two are react to give a ether that may be symmetrical or unsymmetrical, and a byproduct is a sodium halide. Now, which type of alkyl halide required? Now, R dash. So, primary alkyl halide used meaning that is SN2, secondary mean SN2 or E2, and tertiary mean SN2 not possible, only E2 possible. And because here alkoxide is a base. Next, leaving group. Good leaving group required. What are the good leaving groups? Halides, that is called chloride, bromide, iodide, and tosylate ion. TSO minus tosylate ion is paratoluene sulfonate. Now, these are good leaving group. Next, in alkoxide ion, which alkyl group required as a good nucleophile here, because this is a SN2 reaction if it is primary or secondary. Therefore, smaller groups are required, methyl ether. Tertiary butyl is, if you take, that is act as a base only, not a nucleophile. That's why keep in that tertiary butyl I wrote here, that is act only base but not as a nucleophile when tertiary butoxide. So keep in mind here, when both are present, then elimination compete with substitution. Generally, in secondary tertiary is there, elimination is more favorable according to their condition, if temperature or alkyl halide or so alkoxide and respective. So to get the Williamson synthesis, we have to use a smaller alkyl halide. Now here R dash may be same. If it is same, that is called symmetrical ether form. In case R dash may be different, then it form unsymmetrical ether. Keep in mind, it depends upon the what type of alkyl halide we are using. Based on that, symmetrical unsymmetrical ether will form. Therefore, we can prepare in this reaction, both can be prepared, that is symmetrical and unsymmetrical ether will be prepared. One of the example, now I am taking the methyl bromide is a alkyl halide plus sodium alkoxide, that may be methoxide considered, sodium methoxide. Then primary is there, meaning a compulsory substitution, that is SN2 reaction takes place, it form dimethyl ether along with the sodium bromide, byproduct will form. Next, methyl bromide react with the sodium ethoxide, then convert to form, according to alphabetical order, common name ethyl methyl ether, otherwise IUPAC name methoxyethane. Next, another example. Now, in case alcohol is given instead of the sodium alkoxide, then we have to convert into sodium alkoxide. So, methanol react with the sodium. This will be converted to sodium methoxide and half H2 liberate. Then another one, this is a ethyl alcohol. Both are alcohol. Therefore, first react with the sodium methoxide, and this is react with the hydrogen bromide, then it convert to ethyl bromide. So these two again combine to form which one? Sodium methoxide and ethyl bromide. Both combine to form a ether in Williamson synthesis. Just observe here. So sodium methoxide plus ethyl bromide. In this sodium plus bromine, it forms sodium bromide as a byproduct, and methoxyethane is a main product. That is the IUPAC name, common name, ethyl methyl ether. Now another example. Now ethyl iodide. Compared with the bromide, iodide is a good leaving group. React with the sodium ethoxide. Then here it form a symmetrical ether, that is diethyl ether. Which one that is a diethyl ether? And sodium iodide as a byproduct. So here primary alkyl halide used, therefore substitution reaction takes place over the what you call elimination, but small amount of maybe alkene form. That is called C2H4 alkene may be possible. Another one, now I am taking 2-bromopropane. This is a secondary alkyl halide react with the sodium methoxide. Now methoxide and act as a base also, nucleophile also. Now secondary is there, meaning there is a competition. Substitution reaction plus elimination reaction both takes place. Substitution is less favorable than the elimination. Therefore 80% of the E2 product is favorable than the substitution. If you take the another one, what you call tertiary butyl bromide, react with the sodium methoxide ion, then methoxide ion good nucleophile also, good base also. Therefore, if tertiary is there completely, which one elimination is a major product, substitution not at all possible. That's why I'm writing only elimination product, that is called 2-methyl propene. Next, for example, we have to prepare the tertiary group bonded ether. Now this is a tertiary butyl group bonded to oxygen, another side is a methyl. Like this product, if you want, mean what type of reactant we have to take, or what type of alkyl halide and what type of the sodium alkoxide we have to use to prepare this one. Therefore, you have to break both sides of this oxygen. One is green color, another is a blue color. So now keep in mind any one side break respective. Now I am breaking which one side? Left side, that is the green color. Then if you break that, then I want to prepare the tertiary butyl bromide plus what is the sodium methoxide. Then what will form? Now already we seen that elimination favor. That's why this one is not suitable to prepare. Now right side blue color respective. If you break oxygen methyl bond, then you will get the sodium tertiary butoxide ion and plus methyl bromide. Tertiary butoxide only act as a base, but with the base mean elimination reaction favorable, but with one carbon elimination not possible, there compulsory substitution takes place. Therefore the yellow color product form, whatever here shown, actually not yellow color in the product, this is whatever I shown in the this video, that is yellow color, that is called methyl tertiary butyl ether form. So tertiary alkyl halide undergo elimination over substitution because it is compulsory favor the elimination for E2 reaction. Next one, another one such type of example, methoxybenzene. This is called anisole. So this anisole, how to prepare, by which type of alkyl halide we have to take and alkoxide ion we have to take. Here also two type of bond breaking over this oxygen. One is the yellow color, another is light yellow color I took here. So for example, this yellow color respective benzene and oxygen bond break, and bromobenzene and what you call sodium methoxide. Here reaction not takes place. Reason, aryl bromide or aryl halide partial double bond character, therefore reaction not takes place. Next one, oxygen methyl bond. If it is break, sodium phenoxide ion form and methyl maybe bromide iodide chloride, anyone take. So now you are taken bromide, this will give the SN2 reaction and product form, the anisole product will form. So why here I already explained, but once again here, this is bromobenzene sodium methoxide not useful to prepare this product because aryl halide carbon bromine bond having the partial double bond character because of the resonance. therefore not used to prepare this ether. And that carbon also sp2 hybridized carbon, so somewhat stronger bonder to break that carbon bromine bond, difficult. So these are the reason why alkyl or aryl bromides are not easily participated in the reaction. Keep in mind, aryl bromides are not only here in maybe SN2 reaction, SN1 reaction, in all reaction, not that much easily participate. So one of the question here after studying all these preparations, which of the following ether or ethers can be prepared by using the Williamson synthesis method? So you know that which type of alkyl halide is used and which type of sodium alkoxide ion we have to use to prepare the ether from Williamson synthesis. So now you just observe, these are the options I am giving for you to decide which ether we can prepare by using this method. So one side tertiary is there, one side phenyl is there. So tertiary mean elimination, phenyl mean what is that, bond not break in case alkyl halide we are using. So tertiary alkyl halide is elimination preferable, phenyl it means aryl halide not bond break, so not possible. And second one B, tertiary left side right side vinyl, sp2 can bond not break alkyl halide, therefore not. C, left side vinyl right side phenyl, not possible. D, both side phenyl, that alkyl halide bond not possible to break. E, both side what is there, tertiary is there, not possible because elimination favorable. F, one side phenyl is there, one side benzyl is there, benzyl bromide or iodide are possible, so F possible. G, both side benzyl is there, pH mean benzene next carbon CH2 is there, sp2 carbon sp3 carbon, that is called benzyl, possible to show the ether synthesis. Next one H, left side vinyl is there, right side what you call benzyl is there, so possible any one of the side what you call substitution favorable, meaning that is Williamson synthesis possible. Then I, left side allyl is there, right side vinyl is there, so one side left side allyl is favorable for the substitution. Then J, what is that, left side vinyl, right side what is it, 1 minute, left side what is that, with allyl, and right side is a phenyl, any one side is what is there, sp2 carbon sp3 carbon, substitution is favorable, therefore A, B, C, D, E are not favorable for the ether preparation by Williamson synthesis. F, G, H, I, J are useful. This compound can be prepared by Williamson synthesis. And one of the important characteristics of this Williamson synthesis reaction, now just observe whatever I am writing this compound. So this is one of the chiral compound, ethyl, hydrogen, methyl and OH. This is an alcohol. If it is react with the sodium metal, then what will form? Alkoxide ion form, half hydrogen will be eliminated. So it is a chiral carbon, that's why configuration will be present for this. That's why it's shown with the dash and wedge type representation. So now the product formed is just observe, just OH bond break and the sodium ion will form as a ionic bond. So it is called alkoxide ion. Sorry, I wrote here methyl bromide, not possible because here H will be out already. So unfortunately, I wrote just methyl bromide, not at all possible. Just keep in mind. So here S configuration, if it is S configuration, for next purpose I wrote here. So now in case methyl bromide is taken here, then this sodium alkoxide and as a nucleophile react with the bromine, methyl, then bromine will be leaving group eliminated. But keep in mind as a first one, S configuration meaning a product also S will be there after reacting with the methyl bromide, because this nucleophile attack to the methyl, then this product form. Then here configuration of the chiral carbon is not changed, because here alkoxide ion is giving electron to the methyl group. Therefore, overall whatever the initial configuration is there, that is only final same configuration. Therefore, configuration will be retained as it is. That's why retention configuration will be present. If it is R mean R only present, yes mean yes only present. But sometime inversion also possible. When inversion configuration possible, when retention configuration possible, just you have to observe. First one already I shown the retention in this compound. Now yes configuration as it is that I took here, same alcohol. If it is react with the tosyl chloride, TSCl means tosyl chloride, paratoluene sulfonyl chloride actually this is, then this H and Cl eliminate, then what will form here? Whatever the S configuration there, in the product also same, because chiral carbon not disturbed here. Therefore, as it is, you will get the same product, same configuration product here with the TS. Now, OTS is a good leaving group. Already we studied when you react this one with the any alkyl halide. Take anyone, for example, methyl, this is already as alkyl halide type, but OTS is a good leaving group. Now, sodium methoxide as a nucleophile. Sodium methoxide attack from the backside, and this is OTS is a leaving group. SN2 reaction takes place at a time. Nucleophile and leaving group leave mean this is a SN2 reaction. Therefore, configuration will be reversed. If it is yes mean, then here product should be R configuration form. Therefore, in SN, what you call Williamson synthesis reaction, retention configuration also possible, inversion configuration possible, retention when possible, when alcohol react with the sodium metal, and that sodium alkoxide react with the alkyl halide. When tosyl chloride as a good leaving group you are using, meaning at that time inversion product form. So keep in mind, this is about a clear information about the Williamson synthesis reaction.